Hey guys, so sorry I'm not there today. When you walked in, this is actually the slide that I had made for you. So I want you to take a minute and pause and go find what a least common multiple is if you don't remember. I think you learned it in sixth grade, maybe fifth grade. It's been a little while. So please go find what least common multiple is, come back. When you found that out, find the numbers for 10 and 4. What's the least common multiple for 10 and 4? And we're going to talk about that. Um, I'm going to go ahead and talk about least count multiples. So least count multiple would be like multiples of the number 4 would be like 4, 8, 12, 16, 20, 24, 28, and etc. Okay. Multiples of the number 10 would be 10, 20, 30, 40, and then again, etc. So my question is, what's the least common multiple of these two numbers? The numbers that they both have in common would be the number 20. So 20 is your least common multiple. Now, using that, you need to figure out when you're looking at two equations, like if this answer is no, do I have a variable in both equations that is the same or opposite? If you say no, like example here, okay, is 7x and x the same? No. Is 6y and negative y the same? No. And when that happens, you come over to this box, and I need you all to add this to your flowchart. The equations do not have a variable that is the same. So we need to find the least common multiple for either variable to make sure you get them the same. So here, I can get the 7x and x to be the same. Or I can get 6y and negative 6y to be the same. It really doesn't matter which one I do, but that I have to do one of them. So I'm going to come over here, okay, and we are going to clear this, and we are going to do this problem. So I have, you ready? 7x and x, I think it's plus 6y, and minus y equals 5 and negative 16. So honestly, guys, it totally doesn't matter which one you do. You could do the x's or you could do the y's. Your call. I'm going to go ahead and do the x's. I guess I could do the y's. It really doesn't matter. Let's go ahead and do the y's. So in order to make 6y and negative y the same, what would I have to do? I would have to multiply the y by 6. So I'm not really going to get them the same. I'm going to get the opposite because it's going to be 6y and negative 6y, but we'll talk about that whenever we get there. So now we're going to go ahead and multiply this. So we're going to get 6, and you've got to distribute it all the way across. So you get 6x minus 6y equals, 16 times 6 is negative 96. Okay. And now what we need to do is do our flow chart. Okay. Now that they're the same. Okay. So does it have a variable that is the same or opposite? Yes. We're going to put yes because 6y and negative 6y are opposites. And what does it mean when things are opposite? That means that you add. Okay. I'm using that flow chart now. I need to add. So I'm going to write my equations over here. I want to write 7x plus 6y equals 5. Tonight, baby. Tonight. 6x minus 6y equals negative 96. So what does that do here? That cancels out my y's. Okay. 7x plus 6x is 13x. And 5 plus negative 96 is negative 91. Okay, I'm going to do 91 by 13. And that gives me x is negative 7. Sorry. Yeah, negative 7. Okay, now that I know x is negative 7, sorry, it looks so bad, negative 7. Now that I know x is negative 7, I'm going to go ahead and plug that back in so I can find it for the other stuff. So either question, and actually you could totally use the original one because that would be an easy one. Negative 7 minus y equals negative 16. plus 7 plus 7, I get negative y equals negative 9. So positive y equals positive 9. So my answer here is negative 7, positive 9. All right, let's do it again. Let's talk about this one here. Kayla. All right, so I need to get my x's to be the same or my y's to be the same, right? Here, this one makes it a little bit more complicated, okay? Because if I wanted to get my y's the same, I would have to change both equations, and that's kind of complicated. I don't want to do that. I can get my x's to be the same, though, right? If I have at the top, it's, I don't know if we're getting to that point where it's getting small, or like low on time, but I'll do a second video if that happens. Negative 2x plus 3y equals 3. And then I've got negative x plus 4y equals 9. Okay, so here again, 3 and 4, the least common multiple is 12. So I don't want to make both of these 12. That would be too complicated. But negative 2 and negative 1, and the least common multiple is negative 2. So what I would do is I'd get this, and I'd multiply the whole thing by 2. So ready? This gives me negative 2x plus 8y equals 18. Okay, so now, given just those two equations, do I have a variable that's the same or different? Yes, I do. Negative 2x and negative 2x are the same. Okay, and the same means, goes this way, it means subtract, right? Big subtract. So I'm going to write my equations over here. Negative 2x plus 3y equals 3. And I'm going to subtract negative 2x plus 8y equals 18. Okay. So these are going to cancel out because they cancel out. Okay. 3 minus 8 is negative 5y equals 3 minus 18 is negative 15. So that means y is 3, right? We're going to plug that back in. I get negative 2x plus 3 times 3 equals 3. Negative 2x plus 9 equals 3 minus 9. Negative 2x equals negative 6. So x is here 3. So my answer here is 3, 3. Okay. I have one last thing I want to talk to y'all about, and it's this last question. And it says, I can manipulate these equations to make sure that they were equal. What would I do to accomplish this? There are multiple answers. What would I do to make these equal? Well, I could multiply the bottom one by negative 6. That's one answer. I could divide the top one by negative 6. I could multiply the top one by negative 1 and multiply the bottom one by positive 6. There's a whole bunch of answers here, but you'll notice that these are the same equation. You're going to come across things today where if you multiply, you find your least common multiple and you multiply, you're going to get the exact same equation. So keep that in mind. If they're the same equation, what does that mean? They're infinite solutions, right? Y'all remember that? If they're not the same equation, like if they have two different y's, or not y's, but like here, they have two different c numbers, then that means that they have the same all of this, so they have the same slope. But if they don't have the same numbers, then remember those are no solution. So keep that in mind today whenever you're doing your Pearson. Tomorrow we're going to start with any questions over this at all. So if you need any more help from my videos, then go ahead and go watch the other videos on 4-3. All right. Good luck, guys.